All right, we are moving on to linear regression T interval. Yesterday we did testing for slopes to see if there is evidence of a linear relationship between those two quantities. Now, say we have that evidence of a linear relationship, well, estimate how much is that slope of that linear relationship. Let's give an estimate for that slope of its value. So here we go. There's a couple things. We're going to learn how to do it with raw data first because our calculator can plop out that linear regression T interval. So here we go. So this is we're wondering about the relationship between GPA and the ACT score. So I would imagine that you would anticipate maybe the higher the GPA, the higher the ACT score. So maybe we're going to invest. In fact, that's what the first question is asking. What do you think is going to happen? What kind of relationship? Well, I think there's probably going to be a positive relationship correlation because as GPA increases in general, it's not going to be every case, but I think the ACT scores will increase, generally speaking. Okay. So find the equation of that least squares regression line and write it out in context. So do you remember that I had told you to go to, when you do your calculator, stat calc linreg number 8. So if we go stat over to calc, this number 8 will give us a slope of a b value. Okay, we're kind of getting in the habit of actually doing that. So we're going to do the stat calc linreg number 8. And so that gave me the predicting of the ACT score is a slope of 7.51 and a y-intercept of 1.20. All right, now I'm asking you to create a 95% confidence interval to estimate the slope of the relationship between GPA and ACT score. So let's have a confidence level of how much we think that, what's that range that we can estimate the real slope, because I doubt it is 7.51. That's my one sample. Okay, I really think the other one, we need to get that range of value. So here we go. We're going to panic, but we're not going to do the assumptions yet. Again, we'll hold those off till tomorrow. So beta is our parameter. That's the slope of the relationship between GPA and ACT scores. This is a linear regression T interval, which is easy enough to go to our calculator. Look, I showed you this here. We're going to do the linear regression T interval in the calculator, stat over to tests, and I go up from the bottom. So I go up. There it is, second to last one, linear regression T interval. So that gives us this, and here's my beta. I like to put this here to remind me of that I'm estimating my slope. That's probably not required, but here is that interval. Don't forget to write out your degrees of freedom, which in this case, there were 9 pieces of data, so we had degrees of freedom 7. All right, so now the interpretation. I am 95% confident that the slope of the relationship between GPA and ACT is between 4.46 and 10.56. Now, get these units correct. If you're going to write the conclusion like this, then get the units correct. They're a little trickier if you write a conclusion this way. So it's between 4.46 and 10.56. So now how are units for slope? Remember, slope is y's over x's. So it's the units for the slope are the y units over the x units. So here I have in italicized font 4.46 to 10.56 ACT points per GPA point. Okay? So Here is an alternative way to write this, which might actually make more common sense to you. So let's consider this. And you can write either one of these. I don't care. They mean the same thing. Just do either one of them correctly. I am 95% confident that, and so here I kind of go, for every one increase in the X. Okay, so for every additional GPA point, so that's every additional GPA point, every increase in X, the ACT score will increase. I didn't have to say predicted here because I'm saying I'm 95% confident. That's taking care of that predictability of it, that prediction component will increase between, because here's a range, 4.46 and 10.56 points. So for every additional GPA point, the ACT score will increase between this and this many points. All right. Now, next, we have this printout, and I kind of already, let's talk to you about a couple of things here. So this is, let's see what that says there. This is the calculator printout for the linear regression t interval. Okay, so here's an example there. Now, when you do that, you are able to see the sample slope, which is your b. Okay, so I'm able to see that sample slope b. And I'm able to see my y-intercept, which was a. Okay, now you also can see, remember I told you a minute ago, or actually we had this on our last assignment, this S is the same thing as the standard deviation of the residuals, the errors. So S with little e. Okay, so therefore, so sometimes, I'm asking you for the standard deviation of the slope. Wah, wah, wah. It is not on this linear regression t interval printout. Okay? So you can manipulate it and compute it if you go do the linear regression t test. Let's look at the information that provides. So that gives us a t score. Keep in mind that is not the t star for a critical value. Keep that in mind. Keep those two things straight. This t star, is based off of me saying be 90% confident or whatever. All right. And then it does tell me the sample's slope, the b value. So it does tell me that sample's slope. Okay. And it tells me the standard deviation of the residuals, that S there. Okay. So there are those same things. Well, the t score, which we didn't have before, the sample slope, and then there's the standard deviation of the residuals that we saw up here. Okay, but guess what? Standard deviation of the slope, if all you have is your calculator, it is a pain in the butt to calculate. B over T. That's your sample slope B over your T score T. Okay, so that standard deviation of the slope is the same thing as your B over your T. In fact, if you wanted to kind of like check that out, if you came over here and you did B divided by T, guess what you'd get? You'd get that number right there. I think you can kind of do that in your head and say that 30.4 divided by just about 15, 14.89 is a little over 2. So this S of B can be obtained from your calculator, but you have to do a little elbow grease to it. Know how. B over T. It's a pain in the butt. B over T. Okay, so if I say, hey, interpret the standard deviation of the slope for this, you could go get the B and the T and then you would have that standard deviation of the slope, which we already had the standard deviation of the residuals. Okay, I'm not going to read those for you because we've been practicing those regularly. Now look here, what percent of variation in the ACT score can be explained by the linear relationship with GPA? That verbiage should ring a bell. That is our correlation coefficient. So I just figured out what that so I just stated what that correlation coefficient was. All right. That's the final little tricky thing. Being able to know how to use the tools you have, whether all you have is the calculator tool, how can we get that standard deviation of the slope? Or if all we have is this computer printout and we have some things missing, how can we handle that? All right, let's do our final way of getting an interval. It is with the computer printout. So here we go. All right, so Thrill Seeker wanted to travel across the large field while being suspended in the air by holding onto balloons. This is making me think of Up. I should have put a visual aid there of the little family, the kids from Up. Okay, the characters. In order to determine the number of balloons needed per pound of weight, he did a preliminary study. He selected a random sample of 20 various sized rocks. That makes me think sample size is 20, DF is 18. He weighed each one of and also determined the number of balloons that was needed to lift the rock. Make a 90% confidence interval for the slope of the linear relationship between the weight in pounds and the number of balloons it takes to make an object airborne. Here's the output that we got. Okay, so here we go. So I like to label my things here. Of course, here's my explanatory variable is the weight, and then the response is how many balloons it's going to take. There's my slope, little b, sample slope. Here's the standard deviation of the slope. Okay, now do keep in mind, this is the t-score, and if we were running a test, this would be the p-value. So I'd say, yes, I'm rejecting that null hypothesis. I have statistical evidence that there is a linear relationship. Okay. Now, let's move on. Panic. We have got to define our parameter. Beta is the slope of the relationship between the weight of the object in pounds and the number of balloons that it takes to suspend it. Not doing the assumptions. This is a linear regression T. Oh, that's wrong. This is a linear regression T interval. Okay. Hope I got that right on the previous page. Let me double check that. Yeah, I did. Okay. All right. There we go. Now, let's do this. This is not as nice and easy as individual data from the calculator. All right. So I want you to remember from the formula chart. It says on the front page of the formula chart this. The confidence interval is that statistic, what we're estimating, plus or minus the critical value, that's T star, that's based on how confident they want me to be, and then that standard error of the statistics. So our statistic is slope. That's what we're estimating. So our statistic is the sample slope, the little b, plus or minus. Our critical value is a T star because it's a T interval. And we're going to have to remember how to get the critical value. We'll talk about that in just a minute. And then the standard error of the statistic is the standard deviation of the slope. That's written up there in that computer printout. So now I'm going to do this. Here we go. There's the slope. So these numbers I'm getting straight from up above. So that I got from the computer printout, the little b. This I got from the computer printout, the S of B. Okay, now let's talk about this critical value 1.73. Remember, critical value in this case is 90% confident. So if I'm 90% confident, 90 confidence level is what's in the middle. You're going to do inverse, not norm of one tail, but inverse T of one tail with however many degrees of freedom. Since there were 20 pieces of data, there was 18 degrees of freedom. So inverse T of one tail with 18 degrees of freedom is negative 1.73, and I don't have to put the negative one, I just put the positive because this plus and minus is taking care of the negative. So there we have it. There is my estimation for the slope of the relationship between the object's weight and the number of balloons. So I can say I am, how confident were we? 90% confident that the slope of the relationship between the weight of an object and the number of balloons needed to suspend it is between 26.88 and 33.93 balloons per pound. Okay, so remember this, if you like to interpret this way, you need to make sure your units are appropriate with y units per x, or you might choose to write it this way. I'm 90% confident that for every additional pound, for every pound heavier the object is, it will take between 26.88 and 33.94 balloons to make it suspend. Okay, that's another way that you could interpret that. All right, there we have it. So 3 things here. Number 1, making an interval with your raw data, pretty straightforward, pretty simple, but if we have to, the other thing I kind of wanted to cover here is if we have to get the standard deviation of the slope and we just have our calculator, we don't have this handy dandy little computer printout, that S of B is a pain in the butt. B over T. All right, so you can compute it from your information, sample slope divided by the t-score. All right, and then you can interpret those. And then our last one, of course, is our computer printout, where we had to know that formula and know how to calculate the critical value based on your confidence level. All right, so good luck to you on your assignment. We are getting very close to finishing this up. We have one more day about assumptions, and then that's it for the learning of this Unit 10. And we have just a little bit in the Unit 11, and then bam, we're done. Going to start doing our review. All right, so good luck to you on your homework.